Okay, now we're going to talk about the calculations for vectors. And here's our first problem. We have a magnitude of 75 pounds, and we have the direction 35 degrees counterclockwise for the positive x, and our sense is right and up. What we want to do is we want to find the components in the x and the y direction. Because just like on the free body diagram problem where we added up all the forces in the x and all the forces in the y, we really have to change everything to x and y in order to work with it and put things together. And we call that the components. So we're going to use our trig here to figure out how much of this 75 pounds is going in the x direction and how much is going in the y. And we're going to use our trig function. So I'm going to start off with sine of this angle, 35 degrees, equals opposite over hypotenuse. And in this problem, my opposite is Fy, and my hypotenuse is the 75. Now I can just use algebra to solve this, multiply both sides times 75. So I have Fy equals 75 times sine 35 degrees. Notice I'm in degrees here. 75 times sine 35, giving us 43.01. Because this was in pounds, this is also in pounds. That's in the y direction. Now I also need to do it for the x direction, which would be cosine 35 equals adjacent over hypotenuse. Cosine 35, in this case the adjacent is fx, and the hypotenuse is still 75. Multiply both sides times 75. So I have fx equals 75 cosine 35 degrees. Plug that in my calculator. Plug that in our calculator, giving us 61.4. Giving us 61.44 pounds in the x direction. So this part here is 61 pounds worth going this way and 43 pounds going that way. Here's our next problem, and I want you to practice this one. Again, here's my vector. It's 75 pounds magnitude, 35 degrees clockwise this time, going down, and the sense is right and down. And we're once again going to find the x and y components. So I'm going to do this a little quicker than we did last time. So I'm just still going to use sine 35 equals opposite over hypotenuse. Opposite is Fy and hypotenuse is 75. Multiply both sides times 75. Plug that in my calculator. Fy equals 43.01 pounds. But this time it's going down. Something that's going down is what sign? Well, that's negative, because going down is negative. Now let's do the x direction. So I'm going to use cosine 35. Cosine is adjacent over hypotenuse, so that's fx over 75. Multiply both sides times 75. Plug that in my calculator, and I get fx equals 61.44 pounds. Now, is that one also negative? No, that's going to the right, and that's positive, so this is positive. Pause and take these notes down if you need to. So here's the real kind of problem we're going towards. What if we have a boat, and we're trying to pull this up onto shore, and there's two ropes attached to it, and they couldn't both, if it's two people pulling, they couldn't both be pulling straight. So they've kind of got it at this angle, and they're pulling it up. How much magnitude are we getting really to pull this boat up on the shore? Well, we're going to take this picture and we're going to break it down into just these two vector forces. So that's what they did here. This is the same picture we just had with the boat. And if you notice, these are actually the problems we just did on the previous page. These are the numbers we got for the first problem we did. And these are the numbers we just got for the last problem we did. Now what I really want to know is what is the resultant force? And the word resultant, remember, means when I add up the forces. So what I need to do is I want to sum, that's a sigma, that means sum the forces in the x direction. What's going in the x direction? Well, I have FAX plus FBX. This one plus this one. When I add those together, I get that my answer is going this way, 122.8 pounds in the x direction. I also need to sum the forces in the y direction. What's happening this way? Well, that's FAY plus FBY. Add these two together. Well, these two happen to be 43.0 plus negative 43.0, meaning that those two actually end up with a sum of 0, meaning that they're canceling each other out. So in the y direction, it's canceling each other out. What does this mean? What this means is that all my force is going straight this way. There's no force that way, meaning the boat's going to move straight onto shore this way. Now here's the next kind of problem. What if it's not going specifically in two different directions that are both even? This one has 60 degrees here, this one has 30 degrees here, and I want to find what is the resultant force on this hook. So what we're going to do is we're going to take this one right here, and we're going to make one problem out of this part, and then we're going to make one problem out of this part down here. So here's the first one. Copy this down and then work this along with me. So we're going to find the x and y components. I always just start with sine 60 degrees equals opposite over hypotenuse. This is opposite, this is hypotenuse. So that's FCY over 300. Solve this just like we did the other ones by multiplying times the denominator on both sides. Plug that in the calculator. And we get FCY is 259.8 pounds, because that's the units we had there. Do the same thing in the y direction. Cosine of this angle is adjacent over hypotenuse. Multiply both sides times the denominator. FCX, plug that in my calculator, and I get 150 pounds. Okay, now remember this just applies to the top part of our hook here. Now I also need to do this part right here. So we're going to make a little vector problem with that one, and I'm going to do the same thing. Sine of 30 equals opposite over hypotenuse. Sine 30 is opposite over hypotenuse. Plug that in my calculator, and we get FDX equals 200 pounds. Do you notice that every time I write this out and I put a box around it, because we're going to come back and add these up just like we did before. So you're going to want to make sure that they're labeled properly and you have them going correctly. Now let's check the sign on this. FDX, that's going in the positive x direction, so we're good on, oh, this should be FDY is the opposite. And FDY is going down, so this answer needs to be negative. All right, now let's do the other one. Cosine 30 equals FDX, which is the adjacent, over 400. Multiply. Cross it out. Plug this in your calculator. Notice that each time I'm writing this out, you should be writing this down every time. If you don't write this down, when we later get to more complicated problems, you're going to get stuck. Write this down every time, even though we're plugging in our calculator. This is what I got on my calculator, pounds. And is that one in the positive direction? Let's check. Yes, that's positive because it's going to the right. So once again, remember we were looking at this hook here, and what we're going to do is take this hook, and then I found the x and y coordinates of this one and the x and y coordinates of this one because I really want to find what the final resultant is. So they've gone through and added them back up. These are the same numbers we just got on those problems we did. And so now we want to sum up the forces in each direction. So the sum of the forces in the x equals these two added together. FCX plus FDX, 150.0 plus 346.4. Add those together on your calculator. And we get, in the x direction, we have 496.4 pounds. A lot of weight in the x. Now we need to do the same thing in the y. Here we're doing these two, FCY plus FDY. FC is 259.8 and D is negative 200. Use your calculator if you have to, though that's pretty easy. That's 59.8 pounds. Why is this lower? Well, because those are going in opposite directions, so they're evening out that force. But what I got is an x and y component. It didn't ask me for the x and y components. It asked me for what is the final resultant force. All together, at the end, what's really the force and the direction. So what they did is they took the x component here, and they made a little triangle. They put that in the x direction, and 59.8, they put that in the y direction here on a triangle. And what I really want is this resultant force here. What is this resultant force? I need the magnitude and direction of it. Well, what kind of triangle is this? This is a little right triangle, so what can I use? Pythagorean theorem. So these are A and B. I'm looking for C. Plug these in. Plug those in, and that'll give us C squared. I'm going to plug it in my calculator. And when I plug this side in, I get this number. Is that my final number? No, because I have to take the square root of both sides. And I get C is 499.98. If you want to round this up to 500, that's okay. So there's my magnitude of my force, and I also need this angle here. How am I going to find that? Well, we're going to use our other trig function. Tan of that angle is equal to opposite over adjacent. So tan of the angle I'm looking for, this is a theta, which we often use for the angle instead of an x. They just do that in math and in engineering. They use theta usually for angles. So theta, tangent of theta is equal to the opposite is 59.8, and the adjacent is 496.4. Now you work problems like this when you were practicing the trig, but I'm going to remind you of how you do it. So I have to use this inverse tan button right here, the one right there. So second tan is going to find this one when I'm looking for the angle, and then I type this in. It's already open in parentheses, so I don't have to worry about that. So I just put that all in the parentheses, hit enter, and it gives me that this angle is a very small angle, 6.87 degrees. And which direction is that? That happens to be counterclockwise. So there's my magnitude and my direction for my final resultant force. Finish taking these notes, then you're ready to work on the activity.